Good morning. This is AV3 Lesson 3. We're going to talk today about the area of a sector. Let's talk about it. Okay, so here is a sector, the shaded region. It's a gray space. It's a fraction of the circle, right? It's a fraction of it. Now, what fraction of the circle is it? That's the question. Well, 30 degrees is what fraction of 360? I don't know fractions. Are you a sad child who doesn't know fractions? Are you? Yeah. 360 is all of it, but 30 is what fraction of 360? Because in this case, 30 is going to be our n. So if I took 30 over 360, okay, what could I cancel immediately in my head? The zeros, right? Just take those zeros and just lop them off, right? So I get 3 over 36. Well, how many times does 3 go into 36? 12. Right? So that would reduce to 1/12. So I'm really looking for just 1/12 of the area of the circle. Now, you have a calculator available to you, but I do want some of these answers in exact form. So the area I could write as 30 over 360. Okay, a fraction of the area of the circle, pi times radius squared. Okay, now sometimes these aren't going to come out to be nice whole numbers. In this case, they won't. It won't. Okay, so I'm going to reduce 30 over 360 to 1/12 and multiply that by, what would 5 squared be? 5 times 5? 25 pi. Okay, so here would be a varsity way to write the answer to this. And it'd be 25 pi over 12 centimeters squared. That'd be a nice way to write that. Good morning. What would an approximate way to write that be? Well, we'd take 25 times pi and divide it by 12 with our calculator. Let me pull up the old TI Smart View here. Okay, so I'm going to take 25 pi divided by 12 in my calculator, and I get, okay, 6.54. If we round to one decimal, it'll just be 6.5, what is it, square centimeters? Something like that. Okay, so I want to show you a trick. Let's say that you have 35 degrees, right? 35 over 360. Anybody reduce right now? Can you reduce right now? Are you good at reducing 35 over 360? No? Okay, so let's say we had 35 divided by 360. This is just a nice little gadget. Okay, yuck, gross decimal, right? Press math, and option number 1 is fraction, and it'll give you a nice fraction. Oh, that's cool. Right, so 7 over 72. Well, that's not over 360. Well, I could multiply both of those by 5, right? Because I had 35 over 360, so 7 times 5 and 72 times 5. So I could, like, say I have 0.25, right? I can write that as a fraction. Well, you know that's 1/4, but it'll give you any fraction you want in reduced form, right? In reduced form. So your graphing calculator has some power to it, okay? Does anybody know what fraction this is? 0.833333333. Anybody know what the fraction is for that? Yep. Nope. 8333. Anybody play basketball? You hit 5 out of 6 free throws. You are an 83.3 repeating percentage free throw shooter. Boom. Oh. Fraction. Hello. Math. Frac. Oops. I didn't mean that. Why isn't it giving me a fraction? What did I just do? I goofed something up. Okay, so it's 5/6. But your calculator can do that shortcut for you, in case you're wondering. Okay, so what's the point? The point is this. I can write this as an exact answer or as an approximate answer. Now, you are required, if you're going to use an approximate answer and you're asked for it, you have to use this symbol right here, this little approximate symbol, because it isn't equal. It's not exactly 6.5. It is exactly 25 pi over 12 centimeters squared. Okay, so I would like you and a neighbor. Oh, maybe I should do this one. What do you think? Find the radius of the circle. Should I do this one? Yeah? Okay. So I want to find the radius now. That's my unknown value. We're going to call that x. Okay, if the area of the sector is 3 pi, so I know the area here is 3 pi. So 3 pi equals, what is n going to equal? What is n going to equal? It's given. What is it? 30, right? I was given that in the diagram. So now the variable that I'm looking for is r, or in this case, we could call it x. So I know 3 pi is equal to 3 over 360 is the same as 1/12. Pi times radius squared. Okay. So I could basically, in essence, divide by pi on both sides. So that would cancel here and cancel here. So I'm left with 3 equal to 1/12 of r squared. Now what? Somebody other than Reed. How could I get rid of the 1/12? What could I multiply both sides by? Yep. Yeah, multiply by 12. Right? The 12s would cancel. I get on one side 36. Ooh, nice number. Right? What's the square root of 36? 6. I found the radius of the circle. And I don't have to write it in the approximate form because it's exact. It's a whole number. Well, let's continue. Okay. Oh, this is a good one. Find the measure of the central angle. Okay, now the missing variable is not a and it's not r, it's n. We want to find n. So we're given the area is 1.5 pi. We don't know n, but we do know r. All right, so let's clean this up and make it look a little nicer. I got 1.5 pi equal to n over 360 times 9 pi. Okay, times 9 pi. Thoughts? What should I do? Yeah, and I wouldn't even waste my time. If you see a pi on both sides, I would just cancel it. Right? Just get rid of it. You know that it will divide out. There will be a formula later on where that won't be okay, but we'll talk about that later. Then what? Yep. Multiply by 360. Sure, absolutely. Multiply by 360. These will cancel. And multiply by 360. What's 1.5? Is that 540? 540? Okay, so 540 equals 9 times n, right? I got rid of the 360, so I have 9 times n, and then divide by 9. Is it 60? Is n equal to 60 degrees? Cool. Cool. Okay, so for a moment, just humor me here. The three things I want to get rid of are 9, pi, and 360. This is an alternate way to do this. So if I want to get rid of 9 and pi, I want to divide by 9 pi, right? And if I want to get rid of 360, I multiply by 360. So could I do it all in one? Yes, you can. So here the 360s would cancel, the 9s would cancel, the pi's would cancel, and then all I have here is the same thing, 360 over 9 pi. Well, the pi's would cancel over here. 360 times 1.5 is 540, and then divided by 9 would be 60. So there is a way to do it in all one step. But your algebra has to be good. If your algebra is, moving like pond water, then you might have issues, right? If it's not moving, if it's not quality, then you're going to have problems. All right, so Mr. Ludd and Math Magic Land saying out. Like, subscribe, comment below. Hello to Julian, little shout out. Yep, Target, cardboard cuts. And Kylie, what do you do for a job? Oh, yeah, Famous Dave's. Famous Dave's. She's just working hard at Famous Dave's. She goes out in the back. She takes a big chunk of ice and just cuts it up into ice cubes, puts it into the soda machine. I just knew.